Right where I left you, Ben. Don't you like this? How what it is? Wait, is it today? Eh, am I where you left me, buddy? Wait, hold on. Let me grab my book.
In our last video, we looked at the signals coming out of a PS2 keyboard interface and saw that it was a pretty straightforward clock and data serial protocol. Each scan code that the keyboard sends is made up of 11 bits. And then I built this fairly ridiculous series.
So, off the hop, I assume he started with the keyboard, reversed engineered that first, because he's got that age game where it's like Silicon Valley, maybe he's like 12. I didn't hear about him being an aqua blue genius, but I know he is. But I didn't hear about it, physics. So the circuitry on here, the bit game to the letters that spell out stuff, I know it's there. I know, I can see it. I hook up the multimeter, I know it's there. He's right there. So that's my big game of it. So I do it a little different. Like I said, I wanted to do the mask off because I was going to hit the coffee cup for topology. That being a type of the place in which the keyboard, how to get a hold of it and do stuff, come up. I mean, I love his class. I just do it very different. When it comes to computers and the wires, he's got me smoked. He's got me so that it doesn't matter what I do in this universe. I am your slave, sir. What would you like me to do? The government, the world, pressure, derivatives, light bulbs over me and stuff. I like, do it. And I'm like, okay. Quit smoking and do it. I'm not in this class. I'm over here in the universe. They're like...
series of shift registers to capture each of those bits so we could see the different scan codes. We saw each packet of data had a start bit, a stop bit, a parity bit, and then 8 data bits that indicated the scan code that the keyboard was sending. And I also talked about some...
From 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You got an 11-bit section here. But it is 8 because there is 1. And if he was using 5, or it was set up on some count differential over here, these file cabinets are like, again, industrials, banks... that's the keyboard. You got the shift, the tab, the exit, which all have a button tendency about them, but there's a tab, there's a switch, there's a shift. Letters later, when it runs the program A through Z, did it run the sequence? Did it have all that? Take it out of the section, put it over here.
Some ways of interfacing this PS2 keyboard to the 6502 computer project. And of course, if you want more information about this 6502 computer project, you can check out my website, eater.net/6502. I've got a whole series of videos walking through building this and how it works and everything. And I've also got some kits if you want to build your own. But at any rate, what I want to do is have this so that whenever you press a key on the keyboard, it triggers an interrupt, and the CPU will receive that interrupt and be able to read whatever key was pressed or whatever scan code the keyboard sent. And so what I've got here is something hooked up that's very similar to what we had at the end of the video I did on interrupts, where anytime I push this button, it will trigger an interrupt through the 6522 interface adapter.
It's physics whether I do it here or a Navy SEAL drowns me in the pond or in the pool. It's still physics.
And just increment a counter. And so each time I push the button, it's incrementing that. Sometimes you get a couple because the button isn't debounced. Anyway, we get an interrupt every time this CA1 pin here goes low.
So that's the way I go.
So if we want to hook the keyboard up to this, we can connect the keyboard here. And then I've got the pins broken out here. And remember, we need power. So power is black is 5 volts and brown.
Do they teach Droid this way over there? Is that where they do it? They throw their ass in the water and say, if you want to live, you'll stay dry.
Or, excuse me, orange is ground. So we can hook those up to power and ground like that. That'll power up the keyboard. And then brown is clock and red is data. So what we could do is get this switch out of here and actually just trigger the interrupt every time there's a clock pulse from the keyboard. And then the data pin, we could, if we wanted to, just hook up to one of these inputs over here, or these I/O pins that we could use as an input. And ostensibly this would be enough that we could actually read the keyboard value because we get an interrupt.
We're dead here. If it's my job to negotiate these photons through here, we're all dead. You take this.
And to see what's going on here, I could hook up some oscilloscope probes. So I've got the ground here for the probes.
People in the room like, yeah, give me a compass right now.
And then I've got just some wires here that we can hook up the clock and data like that. And then if we press a key on the keyboard, it doesn't work.
Because
And
it's like, what if you need to run somewhere? If I need to run somewhere, I've done something
so
wrong.
Black is 5 volts, ground is orange, and I of course got that backwards here. So let's hook black to 5
I go to their
volts.
boot camp. I'm like, look at your general. Like, I have nukes. You don't.
So we're seeing something, and there we go. We also see the data on the scope. And if I press a key, you see the data for that, but you also see the counter increment. And the counter should increment every time there's a clock pulse. If we reset this, if I press a key...
You would think it's like, it's mine now, and you need a million people.
Press
it's
down
like
on
a
the
million
key, and
people
then it goes
run.
to 33 when I release the key. And that's because when I press the key, we get 11 bits to indicate that the key's down. And then when I release the key, we get 11 bits to say that we're getting a scan code for the key that's being released, and then we get the scan code for the key that's being released. So that's another 11 plus 11, and that gets us to 33 bits.
No, let
So
you
we're
do
getting
it.
an interrupt
I love you
for
too
every
much.
clock
Fast.
pulse. And like I said, we could have the interrupt routine actually read this data bit from the I/O port here, and just read one bit at a time for every interrupt, and from that piece together the entire message from the keyboard. We could do that, but I don't think that's ideal. And the reason for that is, if we look at the timing of these clock pulses, you can see that if we try to measure the period.
I know the
here,
stone mill's real. You know the stone mill's real.
Microseconds.
It's a thing out
In other words,
there.
we're getting an interrupt every 85 microseconds. And, we've got a 1 megahertz clock here, and so 1 megahertz is going to be, one pulse or one clock pulse every
2 pounds a week, 2
So
pounds of
85
barley,
microseconds
right
is
there.
85
You're gonna do it
clock
right
cycles.
here.
So we're gonna get
Well,
an
how much is
interrupt
that? Well,
every
for
85
quantifying
clock
this
cycles.
is the thing you
So that
need,
doesn't really give us
being
the opportunity
gravity.
to run very many instructions
This
per
is what
interrupt.
equates to
another
2
way to look
pounds
at
of
that
wheat,
is
2
if we
pounds of
use a separate
barley.
interrupt
Figure
to
out.
read
And
every
it's like, if
individual
that's 20
bit,
bucks,
we're going to be using a
you
lot of
figure it
CPU
out.
cycles just to read in a byte from the keyboard. When we saw in the last video that we could build a circuit
Why'd
that
you buy
reads all
this
those
instead of
bits
food?
into a
That's my
register
first.
and
Well,
has
those
those
lights
8
ain't gonna
bits
get you there,
ready to
little.
be read, all at once. So we can do that. We can use a shift register
You just
to
wanted
read in
stuff.
those 8 bits and then
Lucky.
present them here on these 8 input bits or these 8 I/O bits for the versatile interface adapter. But then what we need to do is, instead of triggering an interrupt for every bit, we need to trigger an interrupt once we've read 11 bits. And so we could use some sort of counter circuit to do
Just
that,
go get some
where we count
Raspberry
the number
Pi.
of pulses
That's
and
cool.
then trigger a pulse after 11 pulses. The problem with that, though, is if we look at what we've got here, we got 11 pulses for each key code. But if we're just counting them,
I don't know what they are, but that's what they would be. That might be good. That might be bad. If it was me, that could make it bad, make it good.
Bits that we received, or do we maybe count 8 of these pulses and 3 of these pulses? And so if we look at the
You're already too far. You should put every one of those options on a list and then run them, because it's not that one of them might work. What are you doing? Might be a physical law of the universe from your breadboard and how you started. 2 pounds of wheat, 2 pounds of barley. Sickling the bets under the hedge of the car, the points.
Scan codes immediately, one after the other, because this is the signal saying we're releasing the space bar, so that all just happens at once. So there's some
Genesis.
gap in here, and we can try to detect that. And usually when I want to do something with timing like that,
Well, the FDA guy walked on the farm, right, and he's like, I go anywhere I want here. The farmer's just like, you go anywhere you want, but don't go in that cage over there. I go anywhere I want. Look, do not go in that cage over there. Bull comes down, show him your badge.
For the capacitor to discharge through
Shiny.
the resistor. So what I'm doing here is just hooking the clock signal up to an inverter. This chip is a 74HC04, which is just it's got 6 inverters on it. And so I'm just hooking the clock up to that so that we are inverting the clock signal so that we have a high going pulse for each clock, which we'll need anyway for the shift register. So the output of the inverter is here, and we can hook up another oscilloscope probe to take a look at that. So I'll get that connected. And turn that
It's
on.
like smoking for the first time. It's weird you holding it like this.
So that's just the same as the clock pulse, but it's inverted. So let me zoom in there. So we're looking at a single pulse. And so now what we can do with the output of this inverter is run it through a resistor and then a capacitor to ground. So what will happen is when this clock pulse goes high, all of the current flowing out of that pin will flow through the resistor and essentially into the capacitor to charge the capacitor to ground. And so this point here will start out at 0. And then it will
If you watch this, that's what I was telling you. If you watch this, you might one day become an electrical engineer.
And then when the output here drops back to 0, then this point here won't immediately go to 0.
I'm a dreamer, you're a
It'll
dreamer,
stay
why
at
not?
5 volts, and then slowly discharge as the capacitor discharges, essentially through the resistor into that pin that's now at 0 volts. So let's put
This is always
the
going to do
oscilloscope
that.
probe there.
You're going to want to do
Talking
crazy
about.
shit tomorrow. You are not a photon and a
pressing
wire
K,
that abides
there
by
we
the
go.
laws of those
You can
universes.
see that instead of
Maybe if
immediately
you
going
sign
high
the
above,
next,
it's
you do
taking some time to
things
charge
in
and
one of those
discharge,
waves
charge and discharge.
consistently.
And we can kind of change the shape of this by adjusting the size of the resistor and capacitor that we're using.
You would think that.
To sort of change the rate that's charging and discharging. So this resistor I'm using here is just a 4.7K resistor, which I just kind of grabbed randomly.
Well, I wish I had actually somebody in the class. So, I mean, even like people, it's like you run every cabinet of it. All right, she's your girlfriend. She's just somebody. She's in the friend zone. She's in this everything. He's in the friend zone. You're trying to use him to help get a job on.
For something like this, I find it easier just to kind of play around with different values. So we had 4.7K, so that's
crazy. Absolutely crazy.
And this little resistor substitution thing I'm using, it's got a bunch of resistors on the back here, and then you just set these jumpers to set whatever value you want, and then you get that value here. So it's very easy to just swap. It's basically the same as swapping in different resistors, but it's a little bit easier.
Breadboard.
So this should be the same as what we had.
1.
And that looks about the same. But if we go with a lower value, so instead of 4.7K, let's say we go just 2K.
Mu. Vector tensor right there. You see it? You see the tension on the string? Let's push. Alright, we got a pulley over here. Aristotle pulling a Navy ship with this thing.
It's even steeper. But if we go bigger, so
kaiju on the aircraft carrier about to jump it in.
And here, look at this. Let me zoom out a little bit. You see, we just get this kind of big lump here as the clock pulses are starting to blur together. You see, it starts to charge slowly, and then it discharges, and the next clock pulse it charges and discharges a little bit. And so it kind of slowly works
There's
its way
Stripped here. He's hammering that thing back, fucking dropping it down. What?
You can see it slowly starts to discharge.
The temperature spikes up. This thing starts to fuzzle at you.
So maybe let's try 10K, see what that looks like.
Blink? Nah, it couldn't be a blink.
So 10K, it's a little spike here.
Damn if it wasn't.
Because again, it's charging and discharging faster, but still, it's not getting back out.
Like cat was fine until you started poking it with a stick and it fucking blinked at you, and you couldn't figure it out.
At the beginning of the clock pulses, if we can get the signal to kind of go high and then stay like relatively high until we get the end and then go down, then we can use that falling edge here at the end to say like, hey, we've just gotten the 11 bits.
You can always do it again, 12 button pushings later. What did you do?
So I want to sort of dial this in so that it kind of captures the entire event as a single
True,
pulse.
first time analysis works that way.
It
was my stone mill, and this was your terminal over there.
Slope, as the capacitor charges, as well as a slope as it discharges. And that's because it's charging through the resistor and it's also discharging through the resistor. Well, if we want, we can have it only discharge through the resistor by putting a diode across where this resistor is. So this is just a little signaling diode, like a 1N914.
You're going to create heat. You're going to lose it in processing. It's going to start to make a bunch of AI generations, and you're going to forget to click something, right? And this thing's going to start to output just right off the first few steps. All right, moving along. And it's going to start outputting a bunch of ones and zeros at you.
Will essentially discharge immediately. But then, when it goes to charge,
the saw doesn't output weird numbers. Air screen might come up at you, but this rock that you had all pretty lined up in the bay.
So if we look at what happens here,
it'll look like that. You wanted this. Maybe if this, it's real bad. There's something real bad going on.
So we can kind of alter the shape of this in this way as well.
This might even be that. I might have block in here. We could have been dealing with both blocks of it. It's going to skip a block, but it comes off sideways in there.
Let's try flipping
Maybe the bunks ain't right. They ain't got the light up in there. This one's going to come around here.
If we see what this looks like, that's a little more interesting.
If we go back to the breadboard, I'll show you the saws. I'll show you the 5-footers over at Johnson Roads. Like, there you are. You're standing on the catwalk over here. Running up and down, you got thermal station over here. I'm going to click this button. I want that pallet. And put it on the saw over here. Hit some buttons, pump her through. It's going to come back around. And another form over here. Money, more rock.
So that it doesn't discharge as quickly.
Here,
so instead of,
there, on the catwalk. Hello, world. And you're up here, you're burning over here. This is the edge of the universe for the saw. I mean, we put them together. It's like,
it's discharging a little bit slower.
Just one of them.
So it tends to stay sort of more high.
And somebody's like, I need more on here.
The end here and then
I couldn't figure out the first button.
So there's a little bit of a trade-off here, but you can see we're now starting to get this to where we have something that looks like kind of a more defined pulse.
Some of you guys don't
for
have to
each
drive this hot
scan
rod.
code.
That's for sure. We're gonna have
So
to.
that actually looks pretty good.
Skid
So
steer
maybe I'll
Stockholm
replace
syndrome.
this now with
That's what
a
I have a
resistor,
record for. We'll go to that
and this
video.
goes 30K.
I'll be in the stone mill getting
I've
rock
got
out of this
a,
area, taking it and
33K
putting it
resistor,
over
so that
here.
seems
And
close
this
enough.
one's here. And the circuitry
So we'll
works
put that in.
perfect. It's just like, I don't know
Just
what it
verify
is.
that that's
Apparently
working
I'm a
the
Arduino or a Raspberry
looks
Pi
good.
chip.
So now the question is, how do we sort of square this off?
6502
Because this isn't
25604.
really a digital signal anymore. We want this to be a nice, clean square wave that we can feed into the interrupt request pin.
You need the
Well, let's see
you
what
need the
happens if we just feed this
62-9
signal back
gear
into
bolt
one of
over
the
there, and
other
it's not gonna
inverters
go.
on this chip. So we could feed it into just this next inverter here, and then look at the output of that inverter. And so what?
You
what
go
should
to the
happen here,
cabinet,
I
you
think,
find the L
would be
bracket, the
that,
first one.
as
Even
the
if the
signal
boss
gets
doesn't know to
to
tell you
sort
to
of
find
into
that
the,
L bracket, you go
closer
to the
5 volt
inventory and you
high
find it.
territory, then this inverter should sense that as a high signal and send the output, low, and it should be a definite low because this is a digital inverter. And at the end of the pulse, when this starts to tail back off
What do you do?
down to 0, at some point it'll cross some threshold, and it'll detect this input as low again, and then the output should go high. And so hopefully by running it through the inverter again like this, that should convert this like sort of analog-ish signal back into a nice digital signal. So let's see what we've got. Well, there we go. And now we've got a nice digital rising edge here right after we've received all the bits.
Well, we
scan
taking the
code
50 cal through
for
drywall,
and if we
concrete
zoom
or
out here,
steel. What are we doing?
what we should see is we should see 3 pulses for each key press. One when the key is
2
pressed
sheets
down,
of drywall?
and 2 for when the key's released.
3.
So that should be perfect for
We
our
got a
interrupt
house.
handler. So let me go ahead and tidy this circuit up a little bit now that we think we've got something that's working. And so I'm not changing anything here. This is the same 33K resistor.
I mean, letting off black holes in the
This is the
background,
same,
irradiated
0.01
uranium
microfarad
rounds.
capacitor going to ground there, and then the same diode going across.
Like, you ever wonder,
resistor there.
I see that one
Those are
where
all
he's running the
going
board
into
sideways on here, and it's
another
got the
inverter,
long
and
ones.
the
This one,
output
I'm
of that
like,
inverter
looking
is
at this
that
thing, it's
signal,
like, I think you skipped a
triggers
few
the
steps,
scan
buddy.
code.
And like,
So I'm going to connect that to the interrupt input.
me building my droid.
So if
Like,
we
I think,
reset this,
no, I
we can
didn't.
press
You
a
leave
key,
it
we
alone.
should see it count
If
3
you would have known
interrupts.
Omega, you
One
wouldn't
from
have had
the
this
down,
problem,
2
which
from
is
the
my
up.
game. This is where I
Let's go ahead
learned
and do
it.
that.
It brought me
That's
here.
not quite what we got.
Said 9, I was
for
like,
some reason
got
we're
it.
getting 9. Let me try that again. Yeah, for some reason we're getting extra counts here. We're not exactly counting what we think we should be counting. And certainly if we look at the oscilloscope, we're still seeing the pulses that we think we should see. But it seems like for some reason we're counting extra pulses. So let's take a closer
His
look.
AI generations, all
Let's
that
set
thing
up our
crashes. His
trigger
computer just is
for
about ready to
channel
finish the
3,
map. And the
and
100th
then
and
we'll
something
do,
generation where all the
I guess,
neural
well,
nets are
let's see,
running by
rising edge.
evolution. The breeders get to go, but these ones have the best of the
then
breeders.
Zoom this in, and look at that.
Look at that.
For some reason,
You can do that now. Yeah, that's one. Now
that
it's a
rising
trick,
edge
you
is
know.
really
You can
noisy, and I think what's
you can do other
happening
things too. You want to go back
is,
see that
in all
one,
that
have it loaded
noise,
up
we're
autonomously.
counting extra
That's that
counts.
computer
In
engineering
other words, the
stuff. You know
interface
that
after
it's
seeing
supposed to
some
do
extra,
something else.
I guess what it
Actually,
thinks are
it's pretty
rising edges
distant.
there, and counting those as extra interrupts. So what's going on with that?
If that is that.
Let's look back at the
For some reason,
original sort of analog
The
signal
Da Vinci
feeding
Code
in.
movie. Somebody's gonna blow up the place. We better
Trace
run
on
over
that.
there. The program.
Now let's take a
Come
look
back.
at that. And if we zoom out a bit here, you can see what's going
Go
on
to
here.
the swap.
What I think is happening
Call
is as this
them.
green
Do
signal
stuff.
is
Come back
discharging from the
superhero.
capacitor,
Be like, go.
we're passing
Like I
through
heard them. I
this
found them. I
area
did
here
shit,
where
and let them take
really
over
isn't
again.
either high or low.
And then after they get them, you
And
get.
it's kind of right at this area here where we're getting that, I think, ambiguous signal. And actually, if we look at the data sheet for the 74HC04, which is that inverter we're using,
It was
feeding
weird.
that
There's a bunch of them
decaying
doing it at the same
signal
time.
into
We
one
all
of these
kind of
inverters,
gathered
and we're
around that
taking
thing,
out
like.
and we're getting that noise on that output. And then we're feeding that noise in as the interrupt to our CPU, and we're detecting extra rising edges there. And so I think what's happening is if we look at the specs for the input of this,
Gunnery sergeant, come in here.
it specifies a minimum
Tell me right
high
now
level
if he's not in the
voltage
room.
and a maximum low level voltage. So it says anything above, and it's got, I guess, typical here. The minimum input voltage for a high is 3.15 volts, and then the maximum input for a low is 1.35
You in there? You in there,
volts. So
sir?
it says if it's above 3.15 volts, it's going to be high. If it's below 1.35 volts, then it's going to be low. So up here, no problem. This is high, and so the inverter says it's high and inverts it, and it comes out low. Down here, no problem. It's low. It's below that threshold, and so the inverter says that's low, inverts it, and the output is high. But in this little middle range here, it's kind of anyone's guess what it's going to do. And the datasheet doesn't really tell us. It just gives us a minimum high and a maximum low. As for anything in between, no guarantees. And so I think that's our problem. Fortunately, there's a different chip we can use. So this is the 74HC04 hex inverter. And there's a 74HC14, which is a hex.
So I had a job interview over Amphenol a little while ago. I brought my books. I'm telling them about it, telling them about the chess game, right? You're in it right here. They give you the basically an ASVAB gear ratios about, well, this one, the 14, you got to figure out fraction. You realize how bad you are because you haven't used them at all in any sense of the skill set forever. So engineering school, right? And they want you to do some basic gnarling bit job for what it is, but you get an advantage, the shiny light over you for some. And well, anyways, so you get over there and you're actually used to doing equipment and stuff. They wanted you to do a thermaler's position. They didn't really need it. Guy quits, they'd throw you in it. It's like they didn't hire you for that. They said maybe you could do this, but they had a guy. And I've seen them put in a lot of things into there that don't. They literally tell you they don't have the faculties to remember steps like that. And it comes with a test. Because the test makes it provable by calculations that say that's what's in there. So that's what this is when you're basically studying this. Can I make this and can I read this? Can this Jaguar saw program for me? Can this small business model for me? Can this help me with apprentices? Can this break room for me? Because then MM74HC14 hex inverting Schmidt tight trigger, some deadfall in there is just in housing and bottlenecking the topology in such a way where it's like, well, I know this is smoking right now. It's common that those comes up for me, for the saw to break and then completely go through every nut and bolt when I wasn't trained to do that. It's like they say they'll take you through a company walkthrough and then they basically stand you in front of a saw or something, and that's as much as the company you see. You have to meet Larry later, which is a dude you'll need, and they won't introduce him to you. Right, and so that's the part you need, and that becomes on the list. And just like in the inventory or in the geometric location in the inventory where shit goes, there are 8 pieces, and those are the chess pieces, the back row, or your pawns and your back row. So when you're doing that, the game gets a little bit bitty. And like I said, the geometric location is what's important. So for me to read this, there's so much information, which if you're building it step by step, that's great. But let's assume that this is already built. Computer engineering, well, what do I need that for? Computers are already engineered. I'm going to have a hell of a time with some of the things involved about beating Bill Gates and Microsoft, Apple, HP here. It's going to be an issue.
Hex inverter as well, and it's got
I don't have to worry about this. This guy probably didn't invent this because I've heard it from Tesla. I've seen these kind of schematic designs, but don't tell me what this is. But this has scary geometry that's real freaking close to actually the chips that he's using. And that has to do with that code that's inside here. It's a geometric location which act in a certain way. And by doing that, it gives it space. It gives it more entropy for it to make a loop back around and make a different decision. Then this one plus this one give me a different result, which is an action or a code. And from there, from that circuitry, I can double down and say that action or that physical loop or that physical string theory, entanglement, superposition. It wants to be, its energy is running through all of it, even if there's an and or gate with this light bulb that's off, but it's just stacked right there. It's running, it's waiting to do that, but all the current through here is just traveling through here. The second that switch turns over, it's there, and it would change off some other set unless that design wasn't made to do that. And that would be a code design. That would be through here if it does that, and or when it does that, then you get Flappy Birds. And this is you out here, Flappy and Bird. So I mean, like I said, you'll go. They'll teach you this is the bit you need. It has this many gears on it. You're not about to re-engineer this saw, but from those fundamentals, you can actually NP problem this. This is the problem. It's not really a problem, but it's a problem.
It's got a Schmidt trigger, and so the pinout looks pretty similar, right? It looks to be 6 inverters arranged the same way. But if we look at the specs for it, you'll see that it gives a positive going threshold and a negative going threshold, and that's different than what we saw before, where we just had a minimum high and a maximum low. Because what this is saying is that if we have a voltage that goes from, let's say, 0 to 5 volts, the maximum low level is 1.35. So anytime we're below 1.35, that's low over here. And then it says the minimum high is 4.5. So not 4.5, 3.15. So anytime we're above 3.15.
When do you ever get amps
here,
that
that's
high on a system
But it
that
doesn't
low?
say
That's
anything
bullshit.
about what happens in the middle there. And that's where we're running into problems, is our voltage is passing through.
Me alone in the
spending
tool
much
shit, I've
time
never
in
had a
this
problem
region
with
here,
it. You
and it's not
showed
really
up,
sure, well,
observed the thing, and I got electrocuted.
Is it low or is it high? And so we're getting it sort of switching rapidly, and we're getting that noise. What the 74HC14 does is it gives us a positive going threshold and a
You
negative going
thought.
threshold.
Under
So as our
denial,
voltage
sir.
goes from 0 to 5 volts, let's say, we have this positive going threshold that says
The demon.
so
Wobbles.
the minimum and a maximum. Typical is 2.7 minimum and 2.7 maximum. So this is saying as our voltage goes from 0 to 5, when it hits 2.7 volts,
Just working my way through eschatology,
threshold
the
for
pyramid,
it's now a high setting.
catalyst.
and that's a positive going threshold
How's it
because
going?
that says when
In
the voltage
Minotaur.
is going in that direction. But then it also gives a negative going threshold voltage, and that's going to be a minimum of 1.8 and a maximum of 1.8. So 1.8 volts.
Got him in the Pokeball.
Typical. It's
The
got
ball
guaranteed
waddles.
limits and so forth.
He's in there.
But typical is going to be 1.8 volts is the negative going threshold. And so what that's saying is if we're already, up here at 5 volts and our voltage is decreasing, it's going to consider it to still be high until it hits that 1.8 volts. And once it hits 1.8, then it's going to go and say, oh, now that's a low.
Moo? No,
So
no.
if we're going in that
It could be a little bit of Mew. There's
We
almost
have
a
a
Mew in
negative going
there.
threshold of 1.8. And so now it's no longer ambiguous what happens in this region in between. So if our voltage is below,
You're going to start here. Doesn't matter what math equation, what story you're about to rewrite or redesign Middle Earth, you're going to come over. How would Sauron, right? I'm taking over.
1.8, then no question, it's low. If it's above 2.7, then no question, it's high. But then in this region in the middle, well, it sort of depends on where we were before. So if we were high, then it's going to stay high
Stop me.
until
I
it
was
gets
just in that
below
tool shed and I did it and I showed up
3,
with
and then it goes
calculation.
low. Or if it started out low and we're in this region, then it's going to stay low until we go above.
You be my friend, you
So-
want to be my
so that
senator?
should get
That's right,
rid
you
of
are.
the noise.
Say,
And so
hey,
this
photon, you
mechanism
do what I
here
tell
is
you.
referred to
You
as a
blame.
Schmidt trigger. And if you look again
Ben.
Back at the
Keep
symbol
going.
for it, it looks just like a regular inverter, but it has this little symbol in the middle that looks a lot like what I drew.
You get up in the
Although, actually,
morning,
this one
I
appears
get
to
up
be
in the
backwards
morning.
From what I drew, maybe they're trying to indicate that it's an inverter. But anyway, that little symbol there suggests that this is a Schmidt trigger, which has those separate thresholds for going high versus going low. But otherwise, you can see the pinout is the same, and that's very convenient because it means we can just take our 74HC04, pop it out, put in a 74HC14 Schmidt trigger, and it should work the same, except hopefully not be quite so noisy. So let's reset this. And now let's press the key on the keyboard again.
In the same way, unless I'm in
And there
that
we go.
class
We get
with
3
you and I
pulses,
watch
just like
you,
we
we go
expected.
step by step.
And
Did
if
it
we
work?
look back at our
42.
oscilloscope, we see
Alright,
a nice
let's go.
clean pulse there. So just as this decays, bam, there's our transition. So that's perfect. That's just what we want. And if we press and hold a key, we can see it gets the automatic repeat, and then when we release it, we get the 2 scan codes
I am picking a lock.
telling us that we released it. Yeah, each key gives us 3 scan codes. So I think this will work really well.
Because
Now what we need
I'm
to do
not
is when we get that
here
interrupt,
to
it says that
try,
we've got a
when
key
I'm
press
next to
or a
Ben,
scan
if
code
I've
from the
ever in the
keyboard,
world some
we need to
situation or
just
topology
read in
derivative over
the
derivative
value
t
that
makes
we
it close.
set.
Somebody different.
Because the nice thing about this setup here, if we go back and look at the data pin here, we're reading all of the bits.
I'm not going to be this. He knows I'm not going to be
Then
this.
we
This
get this
proof
rising
that
edge
you
right
don't
after
do
this.
that. When that
So if
guy's
we
there,
feed all
you
of
don't
this
even
into the
try.
shift
Touch
register,
none of this.
and then use
You
this rising edge to
watch
trigger an interrupt.
and help
The
him
interrupt
do
handler
that
can read the
social
inside
interaction
shift
thing
register,
with the
and we'll have
military
our scan.
guy and the thing that you do.
So I'm
And
gonna
that's
tidy
the
this up a
servo
little
you
more.
do.
Get
You
the
come in a
oscilloscope
little light
probes
so he
out of
sees
here.
it.
And then replace this jumper. And it's always a good practice to tie
Take it out of the
the
room?
unused
No. I
inputs
want him
of
back. You
gates
put him back
in
in
a
here
higher
now.
row, rather than leave them floating. And then I'll feed the data signal from the
forgetting
keyboard
it.
into a shift register, just like I did in the last video. So these are 74HC595 shift
I didn't like it
registers.
at first. Kick like a damn mule named Sherpa, but I got over it.
Stuff out of here. And I'll connect
Come
power
on,
and
Juan.
ground
They
to
need their
those.
coffee.
And then those need a
Make
clock
the bed.
input from the
Make the bed.
keyboard. And remember from the last video, we do need to invert that. And we're running it through this inverter here, but we don't want to use the output of that because that's got that capacitor to ground. So let's actually use another inverter. So let's take that signal, run it into this third inverter over here, and then take the output of that and run that into the clock input of the 74HT595, and then that same clock.
Gravity constitutionally obligated to just shut you the fuck
that's the shift
off.
clock that's going to clock each time we get a new bit. The 74HT595s also have a latch.
Well, you didn't do leverage. You didn't know physics. You wouldn't understand me well enough as a photon to know where I'm going, how it normally works. That's what it does. It's over there. Try it. This is the one. I did it again. Did time numbers on it. It was like, it'll be there. Clock in, doing its stuff. Then he'd be on the skid steer. Take a dump at lunch, right? Catch him on the toilet. Got him.
Once all of data has arrived. So we can use this same signal that we're using for our interrupt to feed the latch.
Kills you. It's like you live in a little town. It's like you have heroin problems.
Want to latch the data when it's ready. So that'll work perfectly. Then we've got the reset pins that need to be tied high. And the output enable.
And then they bust on you for not having a master's degree in computer science, trying for director of information technology. I'm going to get this guy. My job is to get this fucking guy.
So that should be pretty much everything to get each scan code clocked in and broken out onto the outputs of the 74HT595s. And so now we just need to connect those to the I/O pins of the versatile interface adapter so that the CPU can read them at the appropriate time. And of course, we're getting 11 bits clocked through here.
Kill John Lennon.
But I'm only going to hook up 8 of them, the actual 8 data bits. So I'm not going to hook up the start bit, the stop bit, and the CRC bit. So if I had more inputs here, I could do that. And we could check those as sort of a sanity check. But for now, I'm not going to worry about that.
Lots of colors.
We'll just assume that if we receive a key code, then it's valid. And so just to verify if we...
In the way that you think it would have 40% or 20% or whatever, but it'd kill you.
Yeah, we're
that
counting
must be enough.
Now. But in theory, when we get that interrupt, we should be able to just read the scan code instead of just counting it. So let's modify our code to do that.
I'm marshmallow farming right now.
If we look at the interrupt handler we've got right now, we are incrementing the counter. And then if the counter rolls over, then we increment the high byte of the counter. And then in any case, we do a bit test.
FMA object, it is. It's a neutrino. It doesn't weigh anything.
Which is what is needed to get the versatile interface adapter to reset the interrupt line.
But just...
and then we return from the interrupt. So we're just incrementing the counter anytime we get an interrupt. So what we could do here is, instead of just doing a bit test of port A, we could do a...
The language does. It's only hard-coded that thing in there. We're hacking it.
So this will read
and basically, there might be some different ones, but in the sense, even if one of those created that and all of the language still worked to it, a new Raspberry Pi come out, that wasn't the code. Maybe a totally different business, but same computer, same keyboard. Same gravity, same limitations, same physics. Well, if I looked in there, I'd say Angry Birds, missing a few things in the physics engine, but in general, I suppose the math problem kill enough kids to make it valid.
Sets whether we're looking for a rising edge or a falling edge. Because the way we've got that interrupt request line set up is it goes low once we start getting the clock signals, and then after all the clock
well, if I kill them theoretically, and I don't actually kill them, I drown them and throw them to spring with the bubbles on a cold temperature day over at the Buds team, right? You know, it's like they swim, they hold their breath, they do things, you just hold them down. How what's the temperature today? We teach you by the bubbles. It's a joke kind of thing. You don't want to do physics that way. You'd rather use the spring on the thermometer instead of people swimming around in.
Reset everything. And so the counter is 0 because that's what we initialize it to. But if we press a key,
then you need that over there. It's like, tell me I need a breadboard, buddy. You didn't tell me anything. Feel it raining floor hydromonium and flood right now.
Looks like 41. And that checks out because the scan code for spacebar is 29 hex, and 29 hex to decimal is 41 in decimal. So we're getting 41 because we're converting this to decimal here. And then I think the 0 is because when we release the key, we get that F0 release.
You feel like that.
And F0.
You wouldn't think it because you get paid on the nice sunny days when it's raining. You're not thinking about that cold, shitty spring, early spring where it's still 20 degrees out there, snowing, sleeting on you in the rainstorm. You get paid the same.
Keys, we do see the codes for keys.
Just the density changes it to solver.
We get 28, and the scan code for A is 1C in hex, and so that is 28 decimal. So it looks like we're reading keys from the keyboard. So at this point, we're basically done with the hardware part of this keyboard interface. Although we could certainly make the software much better. And so that's what I'm going to do in the next video, is update the interrupt handler software to interpret those scan codes and be able to figure out if...
That bunny, you think you got it, man. I'll get away from this computer. That thing does a backflip on
characters into a keyboard buffer so that if there's other software running it can just read from that keyboard buffer to see which keys were pressed. And we could use that to read those keys into memory. Or
in the way of gravity, I go
typing on the screen or
Conquest.
whatever else we
Conquest
want to
number
do.
one. It's not plague,
So I'll
it's
dive
not
into that software
pestilence,
in
it's
my
not
next video.
famine, go into
And there's actually already
pollution,
a
it's
draft of
not
that video
war
over on
going
Patreon,
woke.
where I've
And
been getting some really good feedback from my patrons. So of course, as always,
gravity,
I want to
just
say
regular
thanks
old
to,
kill it. You
to
throw
all
it
my
in a
patrons
fucking
for
sun
making
and get
these
it done
videos
over with.
possible.
Hey, that's what you were, feel he. Thank you, Ben.